Okay, so basically what we have found out is that there's two different scenarios. We've got scenario 1 and scenario 2. The scenario 1 is when the legs do not contain square roots. Or in other words, the legs are just some number, and then the hypotenuse is that number square root 2, when it follows the general pattern, when the hypotenuse is that square root 2 times the leg. So in that case, you just follow the pattern. If it's 8, you do 8, 8, 8 square root 2. Okay, our other scenario is when the legs do contain square roots or the hypotenuse does not contain square roots. So in that case, our hypotenuse was the number, and then our two legs was that number, square root 2 over 2, or square root 2 over 2. And to solve that scenario, sometimes it works out nice and pretty, and sometimes it follows the pattern that we have here, and sometimes not so much. So if you ever have a funky scenario that is basically not scenario 1, then your default would be to use the proportion, that however much the leg is to however much the hypotenuse is the same as our similar triangle 1 is to square root 2. Because remember, you can always use 1 for the sides and a hypotenuse of 1 square root 2, or just square root 2 is what I called it here. I didn't write the 1 out front. Right? So when your first pattern doesn't work, and maybe even the second pattern doesn't work, then this is your go-to. Use the proportion. All right, so let's look at some examples. We've thrown in both scenarios. So first of all, my first thought is, does this follow the initial pattern? Is this scenario 1 or not? And this one is scenario number 1 because I have whole numbers for the legs. So 11, 11, x would be 11 square root 2. Let's look at part B. All right, so this time it looks like I have a whole number on the hypotenuse. So this is scenario number 2. Let's see if I need to use a proportion or if there's a faster way. It looks like when the whole number is on the hypotenuse, both of the other sides, the legs, are that number square root 2 over 2. So this one is just 13 square root 2 over 2. 13 square root 2 over 2. Okay, so we're now done with part B since we solved for x in that scenario. So I'll give you a second. I don't know. The U-try looks kind of tricky. Let's take a look. It is not a whole number for the leg, is it? It's 3 square root 2. So automatically we know, whoa, come back. We know the other leg would also be 3 square root 2, right? The tricky part is, what is the hypotenuse? I don't have a pattern for this. It doesn't fit this pattern. It doesn't fit this pattern. What's going on? So when I don't know what to do, this is, friends, when you go to your proportion. Use the proportion is your method. All right, so it says leg is to hypotenuse. My leg to hypotenuse is as 1 is to square root 2 is my proportion. So my leg is 3 square root 2 is to my hypotenuse, which is x, as 1 is to square root 2. And we cross multiply, so x times 1 is x. 3 square root 2 times square root 2. 3 square root 2 times square root 2 is what I get when I cross multiply going the other direction. All right, so how do you tackle this? Well, I can multiply those together since they're both underneath the square root. This would be 3 square root 4. Ooh, I know what the square root of 4 is. It's just 2. So I'm going to call this square root 4 2. So this would be 6, friends. 3 times 2 is going to give us 6. So my hypotenuse is 6. That feels weird, right? To get a whole number, but it really is. Check it out a different way. If we had known that that was 6, if we had recognized earlier that it's basically this situation up here, then that would have made these both 6 square root 2 over 2 for the sides. Well, 2 goes into 6 3 times. That's how they came up with the 3 square root 2 for those two sides. So kind of tricky, kind of tricky. All right, let's look at our next scenario. I don't have a name for this. We'll call it C. All right, so C. I'm supposed to be looking for, Miss Benton forgot to put her X's on there, and we're supposed to be looking for the two side lengths. That's what we don't know in this situation. All right, it doesn't appear to match the first scenario. It's not side, side, and then something square root 2 on the hypotenuse, because this isn't, it doesn't look like something square root 2 to me. Okay, let's check out my other scenario. It's not a whole number on the hypotenuse, so let's use our proportion. That's going to be my strategy. When it's not one of the other two, use your proportion. Okay, so here we go. My proportion is leg to hypotenuse as 1 is to square root 2. This is always the proportion you use, friends. There's no other proportion you would need. So my leg is x. My hypotenuse is, it looks like square root 34. Here, let me erase this square root 2 because that didn't apply in this situation. All right, as 1 is to square root 2. All right, so we cross multiply x times square root 2 equals 1 times square root 34. I'm just going to call that square root 34 because 1 times anything is itself. Ooh, how do I solve this? Okay, it looks like since x is times square root 2, to get rid of the square root 2, I divide by square root 2 on both sides to get x by itself. Can I simplify 3/4 and 2? Aha, you can because they are both underneath the square root. So 2 goes into 34 17 times. You can call it 17 over 1 if you want, same thing. But I do not even have to rationalize, friends. So some of you right here saw this and you thought, ooh, I got to multiply top and bottom by square root 2. Remember, before we do that, we always want to ask ourselves, can I simplify? Can this number divide evenly into the top number? And since it could, I'm done. I didn't even have to rationalize. X is square root 17. Okay, let's look at another one. We'll call her part D. I didn't give you guys very much room. All right, here we go. So this time, I need to know my hypotenuse. I already know that this other leg is square root 5 because these are always the same amount. Let's look at our options. Scenario 1 would say that our legs are whole numbers and the hypotenuse is some number square root 2. That doesn't seem to fit. All right, then we have the option of our hypotenuse being a whole number and our legs both being square root 2 over 2. That doesn't seem to fit either. All right, so then our only other option is dun, 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 the proportion. All right, so here we go. We're going to use the proportion. So leg is to hypotenuse as 1 is to square root 2. Ready? So my leg in this scenario is square root 5. My hypotenuse is x as 1 is to square root 2. We cross multiply. X times 1 is x. Square root 5 times square root 2 is what you get when you multiply the other direction. Since those are both under a square root together, you can multiply them together and you get square root 10. That's it. That's your answer. Your hypotenuse is square root 10. So for some of you, that made sense because you were thinking this whole time that this is n, and this is n square root 2. So square root 5 for n, if I replace n with square root 5, times square root 2, isn't that square root 10? Okay, so just another way of thinking about solving that same triangle. Do whatever makes the most sense to you. Okay, so I've got, looks like 2 u tries. We'll make this u try 2 and u try 3. Okay, and put some x's on there so that you know what you're solving for. Whoops, that's not x. That's square root 20 over there. This is x. There we go. All right, so pause the video, try for yourself, and we'll come back and we'll talk about it. Okay, so I had to erase some of the stuff from these other problems we worked. I don't know about you, but my notes are getting kind of cluttered. So here we go. So again, looking at the pattern, you try 2 does not seem to fit with n square root 2 on the hypotenuse for me. Likewise, it does not seem to fit with the whole number on the hypotenuse. I can't talk. So let's go for the proportion. I'm just going to abbreviate this time. Prop. All right, so leg is to hypotenuse as 1 is to square root 2. This time my leg is x. My hypotenuse is square root 48. 1 is to square root 2. We cross multiply. X square root 2, or x times square root 2, equals 1 times square root 48. I'm just going to call that square root 48. We divide both sides by square root 2 to get x by herself. Those square root 2's cancel. And before, stop, put your pencils down, do not go on. So many of my friends right here want to rationalize. But remember, before you rationalize, you always ask yourself, can 2 go into 48 first, right? So since 2 can divide in evenly to 48, since these are both underneath the square root, you can do that. Since it divides in, you get square root 24. But wait, there's more. What? Miss Benton, no. Yes, we can factor tree 24, friends. Come over here to your side work. 24 breaks down into 6 and 4. 6 breaks down into 3 and 2. 4 breaks down into 2 and 2. So we get 2, what? 1, 3, and 2. Can't count. 1, 3, and 3 2s, it looks like. 1, 3, and 2 2s. So we have a pair of 2s. So our final answer, it appears, is 2 square root 6, because we had a 3 and a 2 left underneath. Phew! That was quite the problem, my friends. Quite the doozy. Let's look at you try 3. All right. Couple of different ways you can attack this. I'm just going to go look at my scenarios. This does not seem to fit the pattern whole number, whole number, whole number, square root 2 for the hypotenuse. It does not seem to be a whole number on the hypotenuse, so square root 2 over 2 for the other two. So I'm going to have to use the proportion. So here we go, proportion. So leg is to hypotenuse as 1 is to square root 2. So my legs this time are square root 20, both of them. My hypotenuse, that's what I don't know, is x. And we cross multiply. So x times 1 is x. Square root 20 times square root 2 is what I get when I cross multiply going the other way. So that's what? That's square root 40. So am I done? Is that my final answer? Heck no. We get to do the factor tree again. 40 breaks down, friends. 40 breaks down into what? 4 and 10. So 2 and 2, 2 and 5. It looks like 3 2s and a 5. So my final answer is 2 square root 10 is what my hypotenuse is. All right, so you've got a worksheet here to finish. First thing you need to do as you look at each of these problems is diagnose which situation you have. Do you have a whole number for the sides? Do you have a whole number on the hypotenuse? Or is it neither of those situations where you need to set up a proportion, like with number 7 will be a good proportion problem. Okay, don't forget to simplify radicals whenever you can, and to factor tree if you need to. Okay, so this will be your homework, is to finish this worksheet. We'll meet back up on Tuesday. Okay, thanks guys.